Hey everyone, welcome to Pittsburgh.NET user groups meetup. Today we're going to look into 10 things .NET developers needs to know while using the CosmosDB API for NoSQL. And we have our presenter, Santosh Hari. I will include Santosh. Hey Santosh, welcome to the group.
Hey Bala, how are you?
Hey, pretty good man. Thank you. And if you would like to give a quick introduction and get started, stage is yours.
Sure, thank you. So a quick intro about myself. I'm currently working at Microsoft. I come from a extensive background in consulting and startups. I used to be a Azure MVP before I joined Microsoft. And then I also helped organize the Orlando.NET user group and Orlando Code Camp for nearly a decade. If you want to get in touch with me, the best place to do so is LinkedIn, as you can see on the slide. So with that, I will jump into today's topic, which is 10 things .NET developers need to know while using Cosmos API for NoSQL. And this is a mouthful, so I'll explain everything. So we'll start with what is Cosmos DB and what is the API for NoSQL. So quick intro to Cosmos DB. It's a fully managed database service. It stores NoSQL data, relational data, and vector data. Vector data is used for AI. And you can perform reads and writes with single-digit millisecond latency. So that's one of the huge selling points. It's also very easy to globally distribute your data with Cosmos DB. So you can do so with the click of a button. And being on Azure, Cosmos gives you Azure-based availability, which is 5 nines availability and security features like Entra and Key Vault integration. So basically, you're connecting to your data using an API. That's what is happening underneath it all, and then you can manipulate your data as needed. So what kind of relational data does Cosmos support? Cosmos supports relational data models through its Postgres SQL API. This allows you to use familiar SQL
Santosh,
syntax.
sorry to interrupt. Are you moving through the slides, or are you still seeing the first slide?
Oh, you're still seeing the first slide?
Sorry about that. Yeah.
Sorry about that. Thanks for letting me know.
Yeah, no worries.
Okay, 1 second.
Yeah, now I can see it. It's all good.
Okay, it seems like it's taking a while to sync up. Very interesting. Okay, I will keep an eye on that one. Thanks for letting me know. Okay, now it's cycling, right? Relational. So
yes, it is. Thank you.
Yeah, thank you. So relational data, Cosmos supports relational data models through its Postgres API. With that you can use like SQL syntax, which is very familiar to you. You can leverage your existing SQL skills. It supports transactional support, like asset transactions for your applications, and you can integrate with other Azure services. So the vector data that Cosmos supports, this is new, but with the rise of AI, Cosmos also now supports vector data, which is useful for AI and machine learning applications. So key features include vector embeddings, in which you can store and manage high-dimensional vector embeddings. You can do vector search, which is used to perform similarity searches using vector distance. Again, that's a lot of different features. We will not dive into this today necessarily, but it's really useful to know that Cosmos supports vector data. And the best part of it is you can follow an integrated approach. So you can store vector data in Cosmos, you can store NoSQL data in Cosmos, and you can store relational data in Cosmos. And you can kind of cross-reference all of these, which makes it really useful for everything to be so close together. And finally, Cosmos also supports NoSQL data. It has multiple types of NoSQL data it can support. There is a native API for NoSQL, which is the Cosmos NoSQL, which is what we will be talking about today. it also supports MongoDB. So if you have applications that are written to consume data over Mongo via protocol, you can use Cosmos to do that. If you have Cassandra applications, you can bring your data to Cosmos and use the scalability and speed of Cosmos. Gremlin is uh, it's uh, it's kind of a super relational database in that it has vertices and nodes, and these represent entities. So spin up uh, you can spin up like relationships between entities real quick, but it's not quite the relational database in the traditional sense. It's more of like a graph database. And finally, there's a table database, which is the table storage that you're familiar with in Azure. So you can also leverage Cosmos for speed and uh, you know uh, high availability. Uh, Cosmos supports multiple consistency models, and we will talk about that in detail today. So the next question is, should I move all my data to Cosmos immediately? And my answer to that is, as a former consultant, I will say it depends. And what does it depend on? It depends on your use cases. So your use case, Cosmos is a really good uh, database that has high availability, low latency, scalability. So some of these use cases make it really compelling. So if you have like Internet of Things, in which the devices generate massive amount of data that need to be ingested, processed, and analyzed in real time, that makes Cosmos a really compelling data store. A retail application often require real-time inventory management. Uh, you get like personalized customer experience and transaction processing, and that makes Cosmos really compelling. And online gaming, you need to manage player data, leaderboards. You need to keep the game state in real time. Again, you'll notice that I'm saying real time quite a bit. So if you need like that fast real time type experience, Cosmos is a really great database for you. Basically, applications that require faster access to user data, uh, Cosmos makes a really compelling use case for that. There are a couple of workloads I want to talk about: read heavy and write heavy. Read heavy workloads involve a high volume of read operations compared to write operations. Users expect quick response to their queries. So basically, think of it like a reporting app. You don't want it to sit and spin around, right? So that is a read heavy workload, and Cosmos is a really good if you have read heavy workloads, I feel like Cosmos is a really good answer for that. But keep in mind that you cannot use the same database for read and write heavy workloads. So they require slightly different strategies. So for instance, read heavy workloads, you have to make sure you get your indexing right. You have to optimize your query as the queries become more complex. And finally, different queries perform differently at different volumes. So you have to keep all of that and constantly keep optimizing to get good read speeds. Write heavy workloads. Now, those are a different thing. They involve a high volume of write operations. So think of things like logging, telemetry, real-time ingestion, and so on. So you have to ensure that all the writes are accurately recorded and the data integrity is maintained. And then you must also handle high throughput for write operations without doing significant delays. So write heavy workloads have a different type of challenge, which is they can cause disk bottleneck, which leads to performance degradation. You can get locks on database resources during writes, which can cause slowdowns. And then you have to constantly keep maintaining indexes as the data comes in. So again, if you have a workload that is very specific to, write heavy workloads, for instance, a bunch of IoT devices sending in data at a particular period of time. So you have millions of IoT devices suddenly waking up and sending data. That's a write heavy workload. So that's a really good use case for Cosmos. And finally, you'll ask how to migrate from relational to NoSQL data. So Generally, we'll talk about the detailed conversion in a minute, but the general pattern for that is fixed strangler fig, which a lot of software developers and architects are familiar with. So when you're migrating a legacy system to new architecture, you can do this by incrementally replacing specific pieces of functionality. So basically, you create this facade and whether all requests, old and new, go through that facade, and underneath you slowly start replacing the legacy components with new components. So that's the strangler fig pattern, and that's a really good migration pattern for Cosmos DB, or to migrate data from relational to NoSQL. So the next question will be, okay, so great, I'm ready to migrate. Where do I store my data and how do I access it? So uh, so this is kind of a lay of what Cosmos looks like. So you have at the left-hand top side, you have database accounts, and that's what you get when you provision it in Azure. And the database account, finally, you can have multiple databases under that. That's a logical type partitioning, and then you have something called a container. Container is where all your data is stored, and the data is stored as JSON data. So an account can have multiple databases, and each database can have multiple containers. The way it works is when you create the account, you get an endpoint, and you connect to that endpoint, and you can read and write data from there. So the container, besides storing data, it can also store things like stored procedures, UDF, user-defined functions, triggers, and so on. One caveat, until you create a container, you don't really start incurring charges on the Cosmos platform. And how do you access your data? So a couple of ways of accessing, and we'll certainly look at one or two of these. The first one is using keys. We don't generally recommend keys these days unless you use a key vault. The other one is you can use something called Entra security role. And that is, you have Azure AD roles, and you can connect those Azure AD roles to work with Cosmos. So the second one is the one I recommend when you work with Cosmos DB. And if you look at some of the code samples, I'll provide you links at the end. You'll see that a lot of them these days are using the Azure AD roles, and they don't use keys. So, containers. So this is how it works. So how do the containers store data, right? So when data comes in, you have something called a partition key. So containers have two types of partitions, logical and physical. A logical partition is kind of like a business entity. So let's say you have an airport, and you have multiple airports, and you're kind of tracking the baggage through the airports or something, right? So what you want to do is you want to make sure that your data is evenly sent to the database. So when the baggage data comes in, it's probably at the business level, it's partitioned by the airport ID. So that is a logical partition. A physical partition is one that actually resides on the system. And the logical partitions are basically stored within the physical partitions. So hopefully that it's not too confusing. Just think of it this way, right? A physical partition is like a hard drive. A logical partition is like different folders within that hard drive. So and your data is like files. The partition key is the one that tells your data where to get stored. So if if I have baggage coming in at Atlanta Airport versus baggage coming in at JFK, those will be different partition keys, and data will get stored in that particular partition. So one thing to keep in mind before you proceed is the choice of the partition key is very important. And the reason for that is the last one on this list, which is if you pick the wrong partition key, you will experience poor performance, and you may have to perform data migration using the correct partition key. You can use most partition keys very flexible. You can use most fields that are string based, and you have to keep in mind that They have to be string only because when you start using double precision numbers, it gets a little complicated. We talked about read and write heavy workloads. So let's get to what the data looks like. Hopefully this is visible on your screen. So document data is what the data is called. And it is the data is stored in JSON format. Each document is like a self-contained unit of data with a unique ID. So the ID field is the one that identifies each record in this case. So every Cosmos record will have an ID field. Uh, However, the partition key can be any property on here. So for instance, in this case, user ID is the partition key. In some cases, it's also okay to have the ID field as a partition key, but I would not recommend that in most cases. So uh, a Cosmos document has at least two fields. One is the ID field, and one is like some kind of data field. And if you have the partition key, that is the second field. So it has to have the minimum of those two fields. Other than that, it can have hundreds of fields, and there's nothing wrong with that. One thing to keep in mind, Cosmos data is schema agnostic. So if you look at the data on the left and the data on the right, you'll see that this they have basically the same two fields, right? They have the ID and user ID. So these two records can be stored in the same container, right? So as long as they have the partition key and they have the ID field, you can store data. The document data can have any of the remaining fields, or they could not have any remaining fields, and you can store them in the same container. So that is what is called schema agnostic. This flexibility allows you to evolve your data without downtime. And so how does that work? So this is it's very interesting, right? So look at this particular JSON data on the left. So it says locations, country, Germany, city, Berlin, and so on. And then you have headquarters, country, Belgium, employees 250, and so on. And then you have export city, Moscow, and so on. So when Cosmos gets this kind of data, it kind of puts them into a tree structure. So you can see that locations 0.country points to Germany. So that's an index. And then the next index is headquarters country is Belgium, or headquarters employees. So as the data comes in, Cosmos automatically indexes the fields in tree format and stores them in the database. That way it makes it extremely easy to reference this particular data. So if I'm running a query on all the headquarters, it immediately knows to come in here. And if I say headquarters.country equal to Belgium, it knows that it will return this particular record. So hopefully that's not too complicated. I'll jump into a couple of quick things I want to discuss, which is converting relational data into NoSQL data. People always wonder how this happens. We do two things, right? We do follow two different processes. One is it's called denormalization. You can reference data or you can embed data. And this is really easy to understand. So on your left, you have three tables. You have the person table, you have the contact table, and you have the address table. So in a normal relational database, in order to combine data from these three tables, you have to write a query and pull four records from three different tables to compose one particular record. Instead, what Cosmos does is it takes this and it combines them into a single record by flattening the data and storing them in JSON format. Now, as someone who comes from a relational database background, this is kind of going back in time for me, because I was used to doing data that was in this format, like the one on the right. I used to move it to the one on the left. But now I'm doing the opposite. And the reason for that is when you denormalize this data in a single document, it really improves the read performance. So I can reference this data by ID, and that's one single operation instead of combining 4 records from 3 different fields. So that is what is denormalizing. So you see, there's a couple of ways of doing this. You can denormalize by embedding. So you can choose to embed data within a document, and each approach has its own advantages and use cases. When you embed data, it involves related data, including related data within the same document. So in this case, I'm taking the orders from that particular customer and putting those orders in the embedding those orders within the customer record. So that makes, let's say a customer has 10 orders, it automatically goes, you'll see an array here, and all those fields are included here. So that again makes retrieval super quick for those customer records. So that is called embedding, because you'll see that I'm including the entire record in here. The other way of this, by the way, embedding is really useful when the data doesn't change frequently. So in this case, let's say there's like a bunch of orders, like 10,000 orders, and there's about 100 customers. Each has about 100 orders, and orders don't change that frequently, right? So maybe in 10,000 you may get like 10 records that change over time. So if you have data that doesn't change frequently, you should consider embedding it during denormalization. And the other way of doing this is denormalizing by referencing. And basically what this means is that the data that is, instead of embedding the data, I'm actually referencing the data by ID. So in here, in this customer record, I have order IDs field that has order 1 and order 2. And order 1 has its own record. So in order 1, I know it's related to the customer because I reference the customer field. So instead of embedding that entire document, I simply am using the IDs as reference. Referencing is really useful when the data changes frequently. So let's say in this case, let's take an example, right? Instead of order, it is like a social media profile or something, right? That changes frequently. So if I want to create something from a social media profile, I may want to consider referencing certain records like my posts, because my posts may change or my feed may change and so on. So that is a very good use case for referencing. So here's a quick look at when to use embedding versus referencing. You use embedding when there are constrained relationships between entities and the related data is queried together frequently. And as you can see, the data changes infrequently. Referencing, you use that when there are one-to-many or many-to-many relationships, and the related data could change frequently. Oh, that's the third one is also important. Like you could have the reference data. So for instance, let's say I have my social media profile and posts. The posts under my social media profile keep growing, right? And instead of that, if I take something like, me and my family record doesn't grow that frequently. So the family record may be a good example for embedding. And the other referencing, I could go with my social media posts. Hopefully this makes sense. Well, is there any questions, anything, or can I keep proceeding?
There is not much at the moment, Hari. If there is anything.
Yeah, sure. I'll just keep moving on.
Okay,
Thanks for that.
I think there is one question. Hold on a second. Why is there an ID and an user ID?
Why is there an ID and a user ID? Is this the one you're talking about? Why is there an ID and a user? Okay, so good question. So, like I said, Cosmos is a schema agnostic database. And the only field that is ever needed for a full Cosmos record is the ID field. The ID field is basically the pointer to which you point and pull that record, right? The user ID is, in this case, is the partition key. So, let's say I am storing, different, like, in this case, my contact information, right? So my contact information is stored, and I could also store in that partition something like my, my all the uh, contracts I have on my uh, home or something like that. And all those use the partition key user ID. So an ID you can reference directly. A user ID is the partition key or the records that are kind of stored together. Why it's important is whenever you run a query, you always have to make sure that your query uses a partition key for maximum efficiency. When I say for maximum efficiency, what happens is that if you use the partition key, all the records are stored physically together. So let's consider trillions of records, right? I'm not even talking billions, trillions of records. So if I'm just referencing by ID, that may happen, but that's not useful because that's only one record. I want to pull a bunch of records in a query. So that's when I use a partition key like user ID. And what that does is it goes and looks at that particular partition that could have, 1,000 records from that trillions of records. And having that partition key is very important for using for running queries. Hopefully that makes
Yeah,
sense.
and
If
also
not,
there is a follow-up from Sriharsha here. Is ID and partition key combined makes the record unique? That's what you answered, just confirming.
yeah. So what makes the record? Yeah, there's also something called a unique key in which you can combine like multiple items to make a record unique. Kind of, that's besides the point, right? So we are looking at two things. I want to pull a record, I use the ID. B, I want to pull a bunch of records, I use the partition key. That's kind of how I think about it. But there's definitely ways you can do to make it more unique. It just depends on your workload.
One more question from Ankur. Any tools to convert relational data to a non-relational data?
Yes. There is a Oh, any tools to convert relational to non-relational data? Yes. So you can use tools like Azure Data Factory and others to take a relational database and convert it to JSON format, and you can store point using Azure Data Factory. In Azure Data Factory, like there's this concept called the sink. So you can use your relational database as a source. You use your Cosmos DB as a sink, and you basically convert that relational data to non-relational JSON data and store it in your Cosmos. The Cosmos also has a downloadable tool, I believe, that you can use to migrate data from relational to non-relational. So there are multiple ways to do this. To answer your question.
Thank you. Let's keep moving.
Sure, thank you. So the next question is, okay, that this is all great, right? So I'm a .NET developer now. Show me how to do CRUD. So you have to know a few things, and I'll share the code samples at the end. But I want to quickly talk about this, right? So let me stop sharing 1 second, and I will pull up my Visual Studio Code. Able to see my Visual Studio Code?
Yeah, it's all good. Hari.
Okay,
It's all
cool.
good.
So this is a sample application, and I will drop the link at the end. So this is very simple, right? So this is simply a web application, right? Uh, and the web application has a program file. In the program file, you'll see that there are a couple of things you see. One is I'm connecting to uh, I have something called a Cosmos client. In order to have the Cosmos client, I have to first of all install this library, Microsoft.azure.cosmos, and then I am instantiating that Cosmos client, pointing to that Cosmos endpoint that you get when you provision the database. And then I'm basically saying that use default Azure credential. This You don't have to use default Azure credential. This is the safest way when deploying in Azure. But you can also do other things like use the keys that you get when you provision. Keep in mind that those are less secure. So you will notice that I'm in a couple of things you should start noticing as some of these patterns are on this. So you'll see a singleton pattern here. But either way, I instantiate a client. And then in my, let's see, in the actual service, you'll see that, I use the client, singleton client. And then when I'm running this demo, it first of all creates a database. And I will zoom in a little so that you can see better. So it creates a database if the database doesn't exist, right? And then what it does is it creates a container within that database if it doesn't exist. So, database and container, that was kind of the structure that we saw earlier. And then, you have a product item. So this is a dynamic that I'm using to create a product item. Just a quick, rough, record that I'm creating. And then what I'm doing is I'm using this command called upsert. And upsert is basically a combination of insert and update. So what this will do is it'll check if a product with that ID exists. If it doesn't exist, it will insert it. If it exists, it'll update it with this data. And you'll see that when I'm doing this, I'm still using the partition key so that I make sure that the category is basically the partition key, but I want to make sure that I specify that when I do the insert so it's more efficient. And that's it, right? So I'm basically three or four lines of code. I'm instantiating a client, I am creating a database, I'm creating a container, and I am inserting into the container, and that is it, right? So so I want to kind of this is why I'm doing this talk, is because the code itself is really easy, but there are a lot of considerations to understand while doing this code. Uh, like, why am I doing something like request.charge, right? So we want to understand that. There's a lot of minor items on here that I want to talk about. So I will, if you go to the Cosmos, documents and look at the sample.NET code sample, this is what it is, and I'll talk about this in detail. And with that, I'll get back to my slides. And sorry for jumping around. I wanted to make sure that I showed you what code sample I was talking about. Okay, so these are some of the considerations, and hopefully you can see my slide. And I want to talk about things like the SDK, what is important, like what do we need to know about the SDK, Cosmos client, and so on. So the first thing you need to know is the .NET SDK, right? So when you start, you do a .NET add package command that you can see on the right here. But okay, just be careful with this, right? So if you go and look at the internet, there's code samples. Some of those may say .NET SDK version 2. Do not use that. If you're starting a new project, make sure that you read the learn documents and figure out what the latest SDK minimum recommended SDK version is, and at least use that. You can always use the latest one, but at least at the very least use the minimum recommended. The other consideration is once you deploy into production, make sure that you're at least keeping it up to date with the minimum recommended. And the reason for this is twofold. One is security, right? So we are always fighting a battle against security, and as different items come up, there's different work being done to strengthen security, including your code. So if you use the minimum recommended, you at least have the baseline security that you have, latest security features that you have for your code. So that is one. Second is performance. Cosmos is all about performance. If you're talking about millisecond latency, you want to make sure that you are using the latest version of the code with the latest optimization, or at the very least the minimum recommended version, so that you're getting the performance benefits. Resist the temptation to use an older version, even if you find like a great code sample that, but it has an older version. Second is Cosmos client. So this is another way you can connect. So in this example, you'll see that I'm using the endpoint, but I'm using an account key. So the one I showed you on my code was actually using Azure AD authentication or Entra authentication. So there's different ways of doing this. I would avoid connecting with account key. If you're using an account key, please always use Key Vault. The third I wanted to talk about is the singleton pattern, and this is very important. There are plenty of code samples out there, particularly older ones, in which you create a client and then simply use the client, and next time you want to do anything, you create the client and use it. But instead, you'll see that in the latest code patterns, we have switched to something called a singleton pattern. And if you are not familiar with this, you should definitely become familiar with that. It's something that gets instantiated when the application starts. There are a few advantages to doing the singleton pattern. One is, the Cosmos client is it is what is known as thread safe. So it is recommended that you use a single instance of Cosmos client for the application of your lifetime. So this actually makes it the connection management really efficient. What we see is often we get called into customer base where there are issues, and we will see that there are a lot of open connections, and that is because they opened up connection and forgot to close them, the multiple connections during the lifetime of the application, and they did not close them properly. So that left a lot of connections open, and this as the connection is open and another one tries to connect, that causes slowdown and often causes connection failures. So definitely use the singleton pattern in your .NET code. So when you don't use, you'll see things like increased latency. So because each Cosmos client requires initialization, which includes reading account information and such. And if you're having to do that constantly, that causes slowdown. You see resource exhaustion because each connection takes up one port. So this can lead to something called port exhaustion. Similarly, if you're using multi-threaded applications and you're constantly opening up connections, it can lead to thread pool starvation. So there are different downsides to not using singletons. So definitely use the singleton pattern. The next thing I wanted to talk about from that code sample was create database if not exist. Why did I do that? What are the other options, right? So you will see that in this screen, the first code sample at the top has create database if not exist, and the second one has create database async. They both do the same thing, except the second one does not check to see if the database exists. So you'll have to add additional code if you're doing that and catch that exception that's thrown and handle it. So if you don't want to do all of that extra work, just use create database if not exists. Again, create database if not exists is defensive programming. It's very good to have, but don't use that constantly. Use that once per application or very infrequently, once per application lifecycle or very infrequently, because what it does is it performs a pre-check on the database properties. And it checks to see the database exists. So it's kind of an intensive operation. So you don't want to be doing hundreds of those operations during the life cycle of your application. Second, the other one I want to talk about was insert, or in this case create item versus upsert. So on the left, there is the create item async code, and on the right, it's the same code, but it's using upsert item async. So create item async is best in scenarios where you need to ensure that there are no duplicate items that are inserted. So what happens is when you use an ID and you do a create item, it will not check, and it'll trust that you know what you're doing and try to insert. And if it fails, it will throw an exception. And that's great if you want the items, if you want no duplicate items, right? So it is faster for sure. Upsert item will check to see if the item with that ID exists. And so if you want to simplify the logic of insert and update, you want to use upsert. So upsert is also idempotent, so you can call it multiple times safely without creating duplicates. It is expensive because it performs the check, but it's okay to use upsert as long as you know you're doing the right thing. The other thing you will see in the sample code is read item async versus actual query. So when do you use a read item async versus an actual query? So earlier I talked about ID versus user ID, right? So in ID, you could simply point to an ID, and that's a single operation. You could pull it. That is that a read item async would be a great use case for that. So if you want to directly pull a single record, use read item async. It's super fast, and you get all the benefits of the Cosmos platform. Speed. If you want to pull multiple records, then you use the query. You run the query definition. So that's the code on the right. So you'll see that the sample code has the query definition. So when you need more flexibility and you need to retrieve multiple records, you use the query items. Okay, so that's a quick view of the CRUD application. Now, like I said, Cosmos is a global database. So what are some considerations for global distribution? So, as .NET developers, we're used to SQL Server. SQL Server uses ACID transactions. That is the strong consistency on the left. So if you have financial transactions, where it's crucial to have, when you write the data and read it, if it has to be consistent within that, if it has to be consistent, has to have strong consistency, then that's the one you use. And then you go across the sliding scale. Previously, when NoSQL databases came out, eventual consistency was the only model applicable. CosmosDB then provided, 3 other levels of consistency. For the sake of this talk and to keep things brief, I will say that session that you're seeing in the middle is probably the consistency that you should always work with when using CosmosDB. Because what happens is with session consistency, let's say you have a session open with the application and you write to that application and you read it, your session can see that data immediately. Others outside of that session may not be able to see it immediately, but your session will be able to see it immediately. A good example of that is a shopping cart application, where if I add an item to a cart, I need to be able to see it. I don't care if someone else sees it or not, right? So use the session consistency as default, and then from there you can slide to either side depending on your use case. So, Cosmos, like I said, is multi-region. So, for instance, I can have a Cosmos application in I can have Cosmos database located across the world, like a single database scale across the world. So I can do it simply by clicking on this map, and it takes a few minutes to create a new region. So there are a couple of considerations for this. When I scale, I can say that I have two options of doing that. One is I want to, let's say, let's take an example, right? I'm scaling to East US, Europe, and Southeast Asia, right? So I can say that, when I scale, all my writes still go to East US, but the reads can happen on East US, uh, Europe, or Southeast Asia. So that's one way of doing it. The second way of doing it is I can say that all my writes can go to any of these regions. That is a multi-region write, right? So they can go to any of these regions, and then slowly they'll sync across different regions. So it's two different use cases. The first use case is, think of something like a stock exchange in New York, right? So all that incoming data is quickly coming into New York, and then it's being read by business analysts in Europe and programmers in Bangalore. So they're using that for reporting. So in that case, it's a single region write and multi-region read. But I may have something like an IoT application, which has deployed in New York, Europe, and Asia. So in that case, I will have writes available in all the regions. Now, keep in mind that as you play with these, cost also comes into factors. So as you have more writes and stuff, you start to incur more charges. Hopefully, that gives a quick understanding of that. And for your, how does this impact you as a .NET developer? So the number one thing you should always do is your application should always, let's say you're deploying your Cosmos database in East US, your application should also be in East US, because that's when you get the most benefits of speed. And then there's a couple of things you need to consider. One is, there's this concept of setting application region, which is the right-hand top code. When you use the application region, this will make sure that the writes get redirected to that region. And let's say you're multi-region. In that case, you can set your preferred regions. And when doing so, it will prioritize this kind of tells me, which order to prioritize my regions and for read and write operations. So this is handled by your SDK, but you have to tell your SDK explicitly that, this is, if you want like some particular preference, you have to tell your SDK explicitly. So that's how it impacts you as a .NET reader. So I will go through this next section quickly, and the last ones I'm going to cut short a little bit based on time. It's really important to understand something called throughput for Cosmos, because this is where all your charges are incurred other than storage. Throughputs are measured in something called request units. They are the currency for throughput. They are basically an abstraction of the system resources like CPU, IOPS, and memory. Each operation, whether it's a read, write, or query, consumes a certain number of RUs or request unit. So for instance, a point read, right? A read async that we talked about earlier. For a 1 KB item, if you're reading it in 1 second, that is 1 RU. So read item, that's probably the cheapest operation you can perform. For a write, but if you take that same item and write it, it will consume maybe 5 RUs. So write operation is more expensive than a read operation. And finally, the query it depends. So it depends on your complexity, whether you're using partition key or not. So, if you use a simple query that uses ID field, it could be 2 resource units. But if you use like a don't use the ID field and you're doing a text scan, it could be 100 resource units. So you never know. So but understanding this is important because that is where your charges come. So this is kind of a quick, my quick and dirty way of estimating how much resource units to provision for your Cosmos containers. So generally what I do is uh, I will run the operations locally, right? And I'll capture the resource unit for each operation. And then I'll estimate that in production, there'll be these many number of operations per second. So for instance, if I do a select, and I determine that it costs 26.18 resource units. I will estimate that in production, this same query may be run 100 times, and so I will provision some. So I will need 2618 RUs. Now, this is not the only query that will run. That may be like 10 other queries. So I'll have to combine all of them, and based on how many RUs I consume per second, I will provision that for my container. So great, right? So how do I get how many RUs are provisioned? So this is an example. Again, this is in our sample code. So we are upserting an item in here, right? We are upserting this, and if you see this, there is the last line says request charge, and the request charge, when you upserted the item, you got a response object, and the response object contains contains a property called request charge, and this request charge is what will give you your RU for that particular operation. And one thing to keep in mind is in development, when you write .NET code, you should always know what each operation costs. There is no excuse for this. Like you literally have the response object here, pull it up and record it. And at some point, make sure that you're keeping tabs on this so that you know what your resource units are cost. Is there any way I can, optimize this? So always be thinking about that. So what happens when you run out of RUs? So this is the scary scenario, right? So when you run out of resource units, you'll see this, it's a HTTP status 429. Basically, that means a throttling error. So if you get this, that means that uh, your provision throughput has been exceeded. Now, this is not necessarily a cause for concern. Our Cosmos SDK is actually designed to handle this. So let's say you suddenly got like a influx of data. It's possible that you'll get this error, but you see this last line on here which says retry after milliseconds 100. So this error will always return like a certain number, and you should be able to retry your operations after that period, and it should work if there are no further requests coming in at that point in time. That will max out the RUs. So that's really interesting, and you really, if you have your Cosmos DB, this is why I tell you to always use the latest SDK, right? As we have evolved through time, we have actually built in things like, retries and other things into our SDK. So this is kind of, a code sample which you can use to, do backups and retries, right? And I'll kind of breeze through this last couple of sections. Just keep in mind that as .NET developers, we need to know a few of these things. So, asynchronous programming is always important. So you'll see that most of the methods here are async. And this is because we don't want to have blocking operations, which are time consuming. So to get max efficiency, always run your operations in async and avoid blocking calls like task.result and so on. So the entire call stack is asynchronous, and you get the maximum benefit from using async properly. Most synchronous blocking calls lead to thread pool starvation. So if you see application running slowly, That is one point to check. You can check to see if there are any kind of blocking in your operation. There is something called a stream API. So, you have a read item async, but you can also have something called a read item stream async. And similarly for writes, you have a stream equivalent. What the stream API does is, instead of serializing, deserializing, it actually handles the data in the raw fashion as it is transmitted across the wire. This gives you a lot of, because you're skipping on serializing, deserializing, it gives you a lot of performance benefits. And it's a great place for middle tier applications where you don't really need to convert the data. You can simply pass it on to the next chain further down. And finally, parallelism. Uh, the max, there's a couple of items in here that you have to know, like max concurrency. Basically, this is the number of partitions and resource constraint, and max buffer items. So this is the number of prefetched items. So understanding and knowing these properties will help a lot when it'll help balance your parallelism and resource usage when you're writing intensive applications. And final point, so I'm drawing to a close. Uh, you get familiar with diagnostic logs. So when you provision your Cosmos, like on the portal, uh, you can actually go to the logs under the Cosmos resource and run something called Custo queries, where you can find out errors and other things that happen in your application. So if you are managing a Cosmos instance, this definitely is very helpful. Uh, Another thing I always tell .NET developers is remove, check if .NET tracer, default tracer is enabled, and remove it. The latest SDK version automatically removes it, but in case you need to remove it, the code kind of looks like the one on the right of the screen. And that's it, Bala. I will share the code samples, and I don't know if you have a way to send that out, or how do you hand? I can put it on the meetup page.
Yeah, you can add it as a comment in the meetup and I can update it. And I have a couple of questions from.
Yeah, absolutely.
You able to see that? So the question is Cosmos DB going to take care of the bottleneck situation?
Okay. Okay, let's see. Which bottleneck are we talking about? There's a lot of bottlenecks. So let's see. There are few items in here. So there's like, the main bottleneck that happens with Cosmos is throughput. So, when let's say you have, you calculated that, I need 10,000 resource units, and you have 100 operations, or no, 90 operations that consume 100 resource units each, and that works fine because it's 9,000, it doesn't exceed it, and it's running smoothly. Then one day suddenly something wakes up and sends like another 90. At that point, yes, you have a bottleneck, and the SDK will kind of take care of that type of bottleneck situation, in which it will see that, oh, I'm getting a throttling error. You remember the 429 slide I showed? So it'll see that error code 429, and it'll say, I'm backing off for 30 seconds, or I'm backing off for 100 milliseconds, or whatever it is, and come after that, I'll retry the same operation. And at that point, if the traffic situation has eased out, it will gracefully write to the database, and you're good to go. But if it doesn't, that's when you get this max retry error type situations. And so, yes, to answer your question, it handles the bottleneck. It doesn't really take care of it.
Other question, same from Harsha. Can we use Cosmos DB for blob data?
Cosmos DB for blob data. Good. Let's see. There is table, but that's not blob data. We used to be able to put blob data, and I don't see any reason you cannot. I would not recommend it. I think Cosmos, the best use for, or the best for best efficiency, I would say all the Cosmos fields are either string fields, or they're number fields, but they're even number fields and date fields have to be carefully handled. So I would stick to the native data types and not use blob. You can probably do it, but like in Jurassic Park, just because you can doesn't mean you should.
Yeah, I was just checking with the GPT, and it's saying like you should be probably using the Azure blob storage, not use Cosmos.
Exactly.
It's not efficient.
Exactly. Yeah. Don't use that. What I would do is I would store my data in Azure Blob Storage, and I'll put a text, like a URL link to that in my Cosmos record. That's how I would do it. Yeah.
Yep. Okay, before we wrap, a quick word here. Okay, and thanks everyone for joining us today. And we are part of the .NET Foundation here. You could visit us in .NETFoundation.org, all the information. And we are Pittsburgh.NET user group, and we host meetups every month in the .NET topics. You could join us in meetup.com, PGHDOTNET. Today's topic, Santosh, thank you very much for spending time on this.
Thank you. This was great. Hope to be back sometime.
Yeah, absolutely. The other thing I want to also shout out for Orchard Code CMS. They have a conference in Las Vegas. It's been scheduled for 12th to 13th September, and they do have the early bird tickets until 15th August. So if you're willing, please visit the URL here, orchardcode.net/harvest. I believe we did not have any questions. If you have any questions, feel free to add it to the chat now. If not, you can always reach out to Santosh on LinkedIn. Thank you everyone for joining us today. See you next month with another topic.
Thank you, folks. Bye.
Thanks.